Welcome to Modular Hippo and episode 10 of the Kiribati 36 aluminium boat build and the playlist where I am going through some of the components that I will be using on the boat. If you are new to the channel, I am trying to build in 2 Seplos battery packs underneath the floor level and use those to drive the boat because it will be an electric setup, an electric motor. So in this episode I will be looking at completing the Seplos Mason battery build and push that bit forward. So let's take a look. To push forward, I've also started to look at 2 new parts. One is number 9, which will be the isolation transformer to make sure I avoid galvanic corrosion as it's an aluminium boat. Saying that, I think galvanic transformers are good for other boats as well because you will still have copper propellers and stainless steel shafts and so on. I'm also looking at an inverter, and the 2 parts I'm looking at is the Victron isolation transformer, 3600 watts, which I think would be enough when you are using shore power, and also the Victron Multiplus 2, 48 volt 5000 watts when it comes to the inverter. If that's not enough, you could always get another one and parallel connect them to increase your wattage to 1000 watts. So if you have any experience of any of these 2 or any reasons why I shouldn't get them, then let me know in the comments and I'll take that into consideration. Thank you. I have now loosely connected all the balancing and BMS cables. The instructions sent over was for the previous model, and Seplos don't seem to have a new instruction manual. So in the previous one they had a loose cable that was going around that was for the what they refer to equalization cable, which I assume was the balancing cable. So I have assumed that the new balancing cables are built into the circuit board's bridges at the top here and connected after that. I've sent Seplos a picture, explained that the instruction manual is very different from the version that I have, the version 3.0 for the BMS, and just asked them to verify that these cables are in the right position. In the last episode I stopped because there was a gap between the compression plate and the batteries. Apparently, according to Seplos, it's enough with just using the additional foam pads that is delivered to fill out the gap. To me it kind of goes against the whole idea of compression, but I am going to take their advice and just put more foam pads on. So there's 7 compression bolts now tightened and it goes all the way up to the edge, so you can't tighten anymore. I can't find my torque measure tool, so I'll need to remember that I will need to tighten them up when I can find it. Next step is to install these the little battery bridges, SFN1. I got 15 of these. If anyone knows why these aren't made out of copper but instead aluminium, then feel free to put it in the comments. I hope it's not aluminium to save cost. Yeah, please let me know. So we now have the bus bars connected, and I think that I probably want to watch out for these 2. If I have an accidental bridge here and I get a short, we have a lot of power and it would go really bad. So if I get tired, I'll stop working on it because I need to make sure I don't do any stupid stuff. So the plus and the minus, stay away from that. We now have the 2 bridges connected, and under the 2 bridges there was a foam protection layer which I put on in the last episode. So I guess the next step will be to start connecting these points to the plus and minus, and yeah, it's time to connect all these balancing wires and charge wires. The diagram I have is not for the version that has an active balancer, so I'm getting a little bit nervous connecting this without consulting Seplos, so I'm just going to send them a picture and ask them to confirm that I have laid out the cables right before I start to attach them to the batteries. It doesn't feel right to me to have the compression plate hitting its maximum position. It means that there's a lot of space, foam space for the batteries to swell in. I've seen batteries swell up to the shape of a football in the past, so I know it will happen at some point, most likely. So I've decided to cut some hard plastic pieces out of the packing material that the batteries came in, and I'm going to use 3 on each side just to kind of decrease that amount of space. I know these boxes are built for many different types of batteries, and that's why there is a bit of a tolerance on that side, and I think in this case it feels right to add it, although it's not something that it's been said that you should, but I'm going to take that risk anyway. Time to make sense out of this box of accessories and see if I can mount stuff to here. The instructions are not very clear, so this will be an interesting endeavor. This looks like a good starting point. We have 4 of these connectors, 2 positive and 2 negatives, and I found 16 little screws. It seems to fit the panel. So let's start with those. With these tightened and in place, I am now focusing on this little bridge that sits here and here. So I just need to find the bolts for that and move forward. So that's those 2 bridge points in place. And now I'm going to look at couple of bridge points that goes from here and here. We have this fuse box holder for a 400 amp fuse, which is going to go here. And I can see straight away that the way that the bridges that goes from each side of the fuse is mounted, this lid is not going to fit unless I cut a hole out on each of the sides. Now you can see what I mean about the fuse lid. I guess I can use it without the fuse lid, but I kind of like it, so I am going to just cut out on both sides so I can use it, because I'd rather have it on than off. Use the normal grinder with a cut disc and just cut 2 slots out on each side, so I can now push that in and it will fit with the bridge arms that comes out. So we now have the negative bridge in place. It goes from here to the fuse, the 400 amp fuse with the modified lid, and then to the circuit board. We now have the 2 bridges in place that will go to the actual battery points themselves. So one that goes from the circuit board and comes up here, and one that goes from the positive in, comes up here. White and black sampling lines that will go to the BSM and balancing bridge that sits on top of the batteries. Put in the front sticker to make sense of the 4 buttons that's there. So let's do that. So film and rubber buttons on, and seem to be working fine. Need to cut some thermal paste and stick under this component there, the little square one, just by my finger there. So we will need to put a piece of thermal paste here before we mount it to the actual battery box. So paste on to the balancing board, and it's now ready for installation. Okay, I've got this far and I have 52 point something, so 52.69 volts. So we're definitely dealing with a live system at the moment. So the 52.69 indicates that all these 16 batteries are connected in series. Otherwise the voltage would have been lower. So I have 2 cables left. I just need to figure out where they go, so I think I'll just make myself a cup of tea and read the manual. Okay, I think that's all the cables. So the last two cables was this one, which is a power cable to the balancing board, and the other one was called a dry cable that went from the balance. Sorry, this one was going to the BMS number, and then the dry cable was going between the balancing board and the BMS. Not sure what the balancing board was doing, but at least it's in place. So in theory, I think I should be able to switch this on now. Just need to figure out if it needs to be charged before I switch it on. Before I do anything else, it says I should do something called capacity learning, which means that I need to fully charge the battery up to 100% with a 100 amp charger, which is recommended, 100 amps. And then you do something similar again up to 50% in some safe mode, and at that point then you can reset it and it should then be ready for use. So I need to set up the Chargeverter so I can charging, and I also need to sort out these connection points because I don't have the male connection points for the positive and negative. I could obviously tap into directly to this point if I order them and I have to wait for them, so it shouldn't have to kind of stop me from moving forward. But that's the next thing I'm going to do, and once everything's working fine, I'm going to tidy up the cables here a bit with some plastic tie bands, and then I am going to leave the second box without batteries so I can lift it in and out of the aluminium boxes I'm going to create. Otherwise they're going to be way too heavy. It's almost 100 kilos plus, so I'm going to keep one box empty until the two aluminium boxes are ready, and then fill that last battery pack up as well. So this is probably a good place for me to stop. In order to connect the Chargeverter to the Seplos Mason battery pack, I've ordered some Seplos Mason battery terminals that will allow me to quick connect those. I have also got two 200 amp cutoff isolator switches, because it says in the instruction manual that you want it to be completely cut off as you connect it, and then at a later stage you will then turn that connection on. To be able to connect the Chargeverter to the mains, I've got some Arctic grade Blueflex cable on order, as well as a NEMA L40 30P female connector to allow me to connect the Chargeverter to the connector that is already on it. I think it's an American version. Thank you for watching episode 10 of the Kiribati 36 wiring and components playlist. If you haven't subscribed, please subscribe if you want to see more. If you have subscribed already, thanks for being a subscriber. If you have any suggestions or concerns, please stick them in the comments and I will respond within 24 hours. And if you're interested in the actual boat build, there is a playlist for that. Or if you're interested in the electrical motor build I'm doing, there's a playlist for that as well. See you next time. Thank you.